Hello everyone, this is another STAAD Pro Connect Edition tutorial. In this tutorial I'm going to show you how to perform a response spectrum analysis. So response spectrum analysis is a dynamic elastic analysis and mostly used for the high-rise building and also for those structure which is located in the seismic area. So in case including the equilateral force method, so this is another method that some could prefer to design the structure based on response spectrum. So this is very popular and it's very effective to understand the dynamic response of the structure. So as example, we have a structure, a steel structure, because we want to design as well. So we consider a steel building, but the procedure is same for concrete building as well. So we have a typical structure, 3x5, 3 bays, each bay is 5 meters, and we have 10 stories, each story has 3 meters. So we're using these two sections, section W12 and W10, and we also have a brassing. So I'm gonna using W6. And the last thing is quite important, the loading. So the load, we will have date plus live load is -5 kilonewton per square meters. And the second is the response parameters. Response parameter is we can say S1, which is short short period of spectrum, and spectrum in 1 second. So we should define these two parameters. So the STAAD Pro is can give you a 2-3 option, then you can give this data to the structure and the program will give you the response spectrum curve. But now we will use another method based on the zip code. Zip code is giving the location of a specific region. So this is just applicable for those code who is included in STAAD Pro Connect Edition. So we'll discuss this inside the STAAD Pro. So we go here and create called the response spectrum design. So we can create analytical model. So this is also applicable for the physical model as well. So for the simplicity, we used structure wizard and using frame model. And this is length is 3 bay 15 meter, and the height is 30, which is 10 story. And this is typical. We use the same 15 and 3. Apply. Sorry, it's a mistake. It was a mistake. So we're gonna go again and we re-edit it. So here is the width 15 meters, number of bays. Okay. What's wrong here? Let me check the unit meters. Okay. I can no, and I want to come back again, and this time come frame here, 15 meter length, and number of bays along the length is 3, and this is 30 meters height, and 10 number of bays along the height is 30, and this is 50, and this is 3. Apply. Now it's correct. Yes, and okay. Now we simply created, and we wanna add the brassing system in the parameter of this structure. So I can go to the one of the view. Let's go to front view, and in the geometry you can add beam. But before beam, let me select this one. Let me go back to the 3D to see, and this is it. So I wanna go to another view, in this view, and I can select you can select the control, and you can select multiple structures. So I'm gonna back again and shift. So you select this one and this one, this one, this one. So now I can see in a 3D I can add a node. On a geometry I wanna insert node, I can select it in the midpoint. So node is added there, and now I'm gonna go to one of the view again, and let's go to front view, and I wanna geometry add some beams. Add beam. I can select this one to here and here. Again I can go to the view. Now I can go to this side, and here, and I can select this one on this side. We also can use rotate. Rotate as well. So in this area we have to create another bracing. Now I can go back to the one view, and I wanna select cursor and called here beam. I'm gonna select this beam. If I go back here, and I can come to this side and press Ctrl and select all. Now I have selected the entire brasses, and I want to duplicate this to the entire structure. So I can use this command translation, and it's in a Y direction. Y is up, and so the number of step is 9, and the story is 3. So before let's say OK, and you can see the entire brass is added. So next I go to properties and defining this section. So I can select section database and defining that 3 primary members, but we can considering an optimization design. So then optimization design can provide us a very specific beam column for the entire structure. Now 3 section is defined, and first I want to apply for the column, the W12, and I want to come to the select here, come to vertical Y, and I'm going to assign it. The second is going to for beam, and I want to select X and select Z. And the last one is for the brass. I can come to the here in the one of the view. This is the view. I can select now the entire brass are selected, and just going to assign. Now I can do a rendering and see how it looks like. And this is the structure. So we will not considering any DAG or slabs for the simplicity, and I can go to define a materials. So I'm using this 50 assigned to view, so the entire structure should be a single material, and this one. Now I can go to the support and go to support, and in the view going to front view and creating a support, fixed support, and here I'm going to assign to the bottom of the structure. So now the support is added. So one more thing that I should say, that in case the bracing is a hinge connection, so that you have to assign a release, you can come to here and then from beam, and you can come to here to this one, and here add a member. It's called bracing. Comes to the specification here, and then in the specification you comes to beam, and you can see here you can add anything you want, like what we expect for the hinges is release. So you can considering release, and if one first we start, or even you can partial moment release. Let's go to partial moment release, and you can specify the moment. The plastic moment should be 0 and X also. So like this you can fix. It's not difficult. So in my analysis, so it's a fixed or rigid connection, so I do not, because it's earthquake area, so I do not considering the hinge connection or semi-rigid or something pane or anything else. So in this time you can add from here, from the beam. And so we are done to here. We go to the loading, and we want to create the load steps or load cases. So we can come to the load case and adding first load. I can use none, and that none should be date plus live load. And the second load case should be seismic load or seismic. You also can select here exactly right here seismic load as well. It doesn't matter, you can give a name, seismic loads. So I'm going to add. Now in this, the first, let me add a date load is self load of the structure, and the second is live load, including the superimposed date load. As a floor load is minus 5 kilonewton per square meters in the height of 30 meter. So now you can see, and this is also assigned to view. Now we two load is added, and the second is we to create the mass for the structure, that you should give these two loads in the all three direction. In case if it's 2D, you can just impose to the 2 direction, but it's a 3D, I will give to entire direction. So it's positive, you can consider positive in all direction. The second is floor load, and the same 5 kilonewtons in maximum 30, and global X, global Y, and global Z. Now the program will consider 100% of this to the analysis. So assign to view, assign to view. So other is already. Now the last step is that defining the response spectrum curve. So you can come to here and comes to the here response spectrum, and from code you can, in case if you it's custom in your country is not included, then you give manually calculate the those data, and you paste it here, the period and acceleration, and then give the direction that you intend to apply the load. So other code is also available. I will use IBC 2000, this one 15, this one, and automatically this is a code which is the location of STAAD Pro office. So I will give my own location. So this 10,005 is the New York City, and automatically the program will get latitude, longitude, and I can change the long period, and this FEA FEV will depend to the classification of the soil. So it's a soft soil, it's D, and the program will determine for us the period and also the acceleration. Now I won't just apply in the X direction, so then I give 1 in case if I want in a both direction. So it's a typical structure, so 1 is okay. When I design, so the program automatically giving a negative for the other direction as well. So you can considering Y as well in case. So but you can change the damping of this graph, so it's 5%, and also you can change the combination method. So I use CQC and adding. Now the seismic load is also added. So this is done, and just we go to the analysis part and defining some miscellaneous command. And I want to define a miscellaneous command. This is 10 story. I want to give 20 cut off mode. So now I'm going to the analysis and going to analysis, define command, and I should say print all. You can add any mode cut off mode shape, and everything is done. So I'm going to run the analysis, and it take a while to finish. So the analysis completed, and we can directly go to the post-processing to see. So here is the seismic, and I can go to the load case to make this one. Okay, and here is the displacement curve from the seismic load. So I can go to summary and see the maximum displacement load is 87 millimeter, and minimum is -1. So we can also see some beam from this seismic load, and you can see here the graph. We also can see the displacement curve as well, and we also go to here, see the mode shape of the structure, and it's the first mode and second mode and the third mode. And we also can create some animation in case if you want mode shape, and you can call apply. So you can see mode 3, and you can any mode you want. So this okay. Any mode. Now next we're gonna design this structure. Well, before that I'm going to the utility, and you can see analysis output. Come here, and this is the eigen solution, and you can see the structure mode shape. This is the mode shape, and the time period is 2.3 seconds, which for 10 stories is almost okay. And the response spectrum loading is here. You can see the first mode shape, weight of the structure, mass, everything, and this is the mode response spectrum curve as well. And here is the base action. So force in the first mode period is 1, 0, and total applied load, total reaction. We are intending to see this one. Here is summary of moment, summary of force in the y direction. So this one in this gravity load, and we can let's come here and see the base shear force as well, a base action. Yes, in mode 2, mode 1 is very little, and mode 2 is this 1 kilonewton. Joint equivalent load, which is so this is all the data you can interpret to see which data is important for you. And center of force base in the XYZ, in the X is this one, and in the Y is this one, in the Z is this one. And okay, this is the data and the analysis. So we go back to the program, and this time we go to the again analytical model and go to design part, and we can select steel, and here we're using this code, and I want to select some parameters. I select OK, and then I go to command. I want to code check, and I want to use select optimization. So the program will give us some optimized parameters. So in this case I will not do it because it takes so much time. The program will do many iterations to get a proper section. So just I want to check it in case if it's fail or pass. So now we're gonna rerun the analysis and take a while. Now again the analysis completed. We can go to the view output file. So now this time the program will show the design of member, and you can see. So this giving mostly these members like member 1, member 2. This member is passed, and you can see this member is passed. And then you can after the analysis completed, design is complete, you can do some beam or something else to create the detailing of this structure. So mostly this with these properties, with this system, the entire member is passed. So this was the design part as well. So if you have any question, please put in the comment and I'll find time to answer you. See you next time.